Thank you, everybody. Barry Byford is going to give us a talk on Bluetooth beacons. Sorry, can you just wire you up first? The other way up.
Okay. Is that working?
You all hear okay? Okay, Barry?
Great. Cool. So the reason that I've ended up having this as my as topic for a talk today is 18 months ago I got invited along to be a STEM ambassador and to help out UK Electronic Skills Foundation on a project they call Go for Set, where they do a 10-week course, and we work with children in school, secondary school children, and we try and identify a problem, solve a problem, hopefully using electronics, but it can just be a report and a cardboard box. But 18 months ago they said, you know, we looked at lots of things, and one of the things that came up was registration was a problem, and they wanted to know when children were in a classroom or which classroom the children were in. So they sort of read about iBeacons, and we looked into that, and there was just no way we were going to do that in 10 weeks. I helped out again this year, and again beacons came up, and I looked into it, and it was too difficult. So after this year's attempt, I decided, right, I'm going to learn about beacons, and hopefully at the end of my learning, I can help next year if I get involved again, or at least run a workshop around beacons, as it seems quite an interesting topic. So this isn't going to be a tutorial. This is just trying to understand the landscape of beacons and kind of what I've learned over the last few months as I've wrestled with this. So we're kind of start at a low bitty level about the technology, but I'll skip over it fairly quickly and try and get on to the interesting stuff. But I thought it was worth just talking about Bluetooth, because most of us have probably touched or used Bluetooth in our time for speakers, or headsets is quite a common one in your car, those kind of things. And actually, Bluetooth low energy is a relatively recent development within the Bluetooth spec. It gets called lots of different things. So Bluetooth low energy, BLE, you'll see, 4.0, but actually its official name is Bluetooth Smart, and it's a sort of new piece of it designed to be very low power. The classic Bluetooth's still there, and if you pair headsets and do audio, it still uses that spec, but this is a slightly different spec. And part of that spec is the transmission only of very small bits of information. So this is sort of what the packets look like. We don't really care about this. The only bit we're going to talk about when we talk about these different beacons, it's this blue bit. The rest of it, I like to think of it as like going to see a town crier. You know, they go, oh yay, and they do all that preamble, which is important that you know it's a town crier and that you're going to have to listen, but the bit that you're actually interested in is the advertisement data within it. So, another piece of the spec that's worth talking about is the receive strength indicator. So you get your peripheral or something transmitting, you get your piece receiving, and it has some idea of how strong a signal it's receiving, and it calls that the receive strength indicator. So as soon as you start looking at Bluetooth and various bits of Bluetooth, you'll see RSSI banded around, and it's useful to understand that's the receiving bit and some idea of the signal. And we'll come back how this can be useful. So the only problem is that it's not a precise measurement. So this is 2 beacons that I had set up at different distances from a receiving thing. They weren't moving, everything was static, it was just in my living room. But there was lots of interference and all that kind of stuff going on. So it's not a fixed level. So this is an important piece of information when we look at trying to range how far a beacon is away. And again, the way I tend to think of this is, you know, if you're outside on a windy day and someone's shouting at you, you don't hear everything at the same volume level. It kind of fades in and out as there's various things. In this room, we've got beautiful acoustics. We don't have that problem, but you don't always have that in the real world. So iBeacons, as soon as you start talking about Bluetooth beacons, people say iBeacons. And Apple have done a really good job of getting out there, making a lot of noise about iBeacons. And so when I went to start looking at beacons and trying to do something, iBeacon was the easiest thing to find. The only problem with it is, for what we're looking to do here, is officially you have to sign up to an agreement with lots of NDAs, non-disclosure, so you know I couldn't suddenly find all the information out by signing up to this and then come here and tell you exactly how it worked. And all of their infrastructure is very much set up for the iOS environment, so that was kind of a non-starter really for me to try and build a workshop for schools around. Then I think the middle of last year, a company called Radius Networks, I think had got into an interesting point where they had been doing stuff with iBeacons and on other platforms, and they weren't allowed to do that. So they seem to have, as a reaction to that, come up with this alt beacon that, from what I can understand, seems to provide a very similar functionality to the iBeacon. And as you can see, this is just the 28 characters that we were talking about earlier for the advertising data of the bigger packet. And really the only things that we particularly care about or are particularly useful to us is that 20 bytes of beacon ID. So that's what gives the beacon its uniqueness. And then there's 1 byte near the end, which is a reference RSSI. So that says I'm broadcasting at this strength. If you're about a meter away, this is what you should see. And that's quite useful because then we can start to range how far away, because we kind of know how the signal drops off over range. If you go behind a wall, it drops off a lot quicker, and people and all that kind of stuff, it messes it up a bit. But you know, again, this is more proximity than exact location. So that was good, but there wasn't very much code around it. I tried writing some Python to actually process that information, and I was kind of getting somewhere, but it was quite hard work and not necessarily particularly valuable work. And then I came across iBeacon, as it's pronounced, and as you can see, there is a GitHub repository for this, and it's under a user called Google. Now, Google go to great length to say that this isn't their product, it's nothing to do with them, but they're doing something that they're trying to do an open standard above this called the physical web, which is really like being able to do a Google search or a search on your physical location and find out interesting IoT things around it. And part of what's in there needs to be a beacon. Again, there's lots of stuff at the front end that needs to be in there, but there's two things that, again, is very interesting for us. So one is this URI, or effectively for most of us it's a URL. It's what we type into our web browsers to go off and find a web page. So that's quite interesting, and again it's got this calibrated TX power, so we know roughly what power this beacon is transmitting at. Has a lot more code around it, and people like these, like Blesh, make production ready beacons that I can go off and program. If I go to my favourite app store, either on iOS or Android, I can download a standard, it's called Physical Web app, that will allow me to program this up to be whatever URL I want. So suddenly, now, I can very easily get some beacons and start transmitting. This GitHub has lots of other things. There's even stuff for the Raspberry Pi, for Embed platform, for Android. Lots of different people are contributing to this, and it's a very active thing. So, looking at those three standards, I think the iBeacon was a non-starter for me because it wasn't an open standard. There was two open standards. The URI beacon seems to be the most actively worked upon, the most people interested in it. It has a flexible payload, so I can do something similar to the iBeacon or the AltBeacon, and it gives me more than that as well with the URI or URL payload. Because it's that URI payload, and there is these standard apps not only for setting your beacons but for searching for the beacons, it means I can do something quite interesting without ever doing any code. So that was quite interesting. And then there's this JavaScript library on there called URI Beacon Scanner. And here's a very simple example. So the top line just imports it, so it's like a Python import. So it says I'm going to use this this library. At the bottom there, we're telling it to start scanning, so start looking for beacons around me. And then JavaScript is event-based, so we create this event handler that says on discovery, whenever I find a beacon, do whatever's in this bit of code. And all we're going to print out here is the URI that's being broadcast, the flags, we don't necessarily care about that, but we have access to it, the reference TX power, and then locally on the receiving part, what the receive strength indicator is. So we can do whatever we want with those things. So the simplest thing is just I be a fancy QR code. Instead of me having to actually find the QR code, get my camera out, get it to focus, I can actually just go here, scan and see what's in here. If anybody had the physical web app on their device, they'd probably be able to take somewhere between 2 and 4 that I'm broadcasting here at the moment. And they'll take you off to various interesting organisations. So one of the things that I'll show later is it can be of a smart thing. So it isn't necessarily just a web page up in the cloud somewhere. It could be a web server running on a smart thing, some smart device here. And it would initiate me being able to interact with that device. And then what looks quite interesting is proximity tracking. So hopefully, if I've remembered my slides correctly, I talk about what we need on the Pi, but each of those three things, I've got an example here of them. But let's talk about what we need to actually use this on the Pi. So we need some additional hardware. We need to make it Bluetooth and more importantly, Bluetooth Smart ready. So it needs to be a Bluetooth 4.0 dongle. These aren't particularly expensive. They're just a few pounds depending where you buy them from. And our Raspberry Pi can either be a beacon broadcasting, or it can be a scanner looking to see what beacons are around. On the software side, you need the BlueZ stack, which is an open thing that basically tells Linux how to interact with Bluetooth peripherals. And then, as I've said, on the GitHub, really JavaScript seems to be the popular thing. So on the Raspberry Pi, we can do this with Node.js. And the Uri Beacon Scanner is a library that I've been using that's very good. And you'll see in my demo later, I switch some LEDs on and off. So there's the onoff.js library as well. So with them, I can start to do something very interesting. So it was really, okay, this looks all great. I found some open libraries. I found an open standard. If I'm going to take this as a workshop into schools, you need to find this sweet spot between it's not going to be a 6-week project, but it's got to do something interesting. So I started looking around for something interesting. So the people that made this beacon, they have an advert, and hopefully technology allows me. This is the advert. And this is really that first use case where it's really just a smart QR code. So he's come along, he's seen the poster, and they've got one of their little beacons next to the poster. So he does the search, and it goes off. So now it's doing the search, so that information has gone there about the web page. He clicks on it, and it takes him to that web page. So that was the simplest thing. It goes off and sort of says that you can do the same thing in different environments. So that looked quite good. But if I was going to take that into schools, it wasn't enough coding really, and we'd have to have web pages and connectivity. And generally, I found when I go into schools that getting all that set up and these foreign objects, because I bring my own devices in. People aren't normally keen for that to happen. So Scott Jensen is a gentleman that works at Google, and he's really out there championing this physical web idea, based on top of the Uri beacon. And he works for the Google Chrome team, and eventually a lot of this stuff is going to be in the Chrome browser. And they're keen to say it's not a Google product because they want it to be in all browsers. But he was trying to sell this idea in Google, and they they kind of said, yeah, go on, carry on doing it, it looks interesting, but they weren't really getting it. So he went out and he bought this old vending machine from the 1970s, and he ripped all the electronics out, he put a Raspberry Pi in there, and he hooked it all up, and here's the demo that he was giving around the office. So that's his thumb. So you'll see the interaction's very similar. They go off, they do the search. It's found 3 beacons this time. He selects the Mars Candy vending machine. He makes his selection, and there it's interacted with the machine, and it's vended his thing. And if you saw on the web page that he had up, so that goes up into the cloud to a thing, and it's got a PayPal thing on there that I don't think does anything, and then that sends a signal down to the Pi to do it, and it all happens very, very quickly. So that looked good, and I thought, wow, that's interesting, that's something that would capture people's imagination. But I can't imagine buying a vending machine and taking that, and I'd need 10 because you know you've got groups of students. And I thought about doing something similar, but it always seemed too big a project, so I kept looking. So there's a consultancy over in Chicago, I think they're based, called Truth Labs. And they did something around proximity tracking. So this actually uses the iBeacon standard, but let's just have a look at what they did. So the little thing in the middle is the beacon. You've got the Raspberry Pi doing the scanning, and then they were displaying the output to the mobile phone. So there he is, carrying the beacon around with him. As he moves closer to the scanner, he's the red dot, and it starts moving closer. And as we can see, it's a little bit jumpy because we know the RSSI isn't necessarily that good. And then as he turns around and walks away, it moves away. And I thought, wow, that looks interesting. But boy, did they have a complex setup. So actually what they were targeting was that they were going to end up with multiple pies around the space, and they would try and do some trilateration to work out more precisely where people were in the space. So that's why they had a fairly complex space, complex setup. So I thought, I'm not going to be able to get all that networking and everything into a school. So here's my far simpler setup. And what I've got is 2 sets of traffic lights tracking 2 beacons. If you're really close, the red light comes on. If it's detected you but you're a long way away, the green light comes on, and then the amber light is fairly close. So this is where it gets exciting. I now switch over. So here you have some traffic lights that are just down here on my Raspberry Pi. I have 2 beacons that I have programmed up myself, and as you can see, there's no lights on. So if I stand over here and switch on beacon 1, the green light comes on, and as I walk closer, and if I go really close, I get the red light. So you can see now that it's got some idea of my proximity. And this looks like, so to do all this, tracking 2 beacons, takes about 100 lines of JavaScript. So that's probably at the level of complexity that schools can understand. And as you can see, as I have my other beacon here, I can walk closer, and then as I start walking away again, it does it. And then if I turn it off, basically in my code I say if nothing's happened for 5 seconds, I'm going to presume that the beacon's left, so I switched it off. So that then goes off as well. So this is very fresh and delicate code. It'll need some beautification before it can get turned into a workshop. But it's been a long and painful journey. But I think I'm actually at some technology that I can take and turn into a workshop. But again, was there a question yet?
Yeah. Are you doing this for students are you doing this for students in schools?
Yes.
So how would that work? Would you have every student carrying around one of the beacons?
Exactly those kind of details are still to be worked out. I think probably the way I'd run the workshop is every student would have a Raspberry Pi scanning for it. They would program up the scanner, and we would have people walking around the classroom with maybe just a couple of beacons, and we'd be triggering each of the scanners. But exactly the logistics is still to work out. But I think I have something that looks promising there. So as I said, this wasn't intended to be a tutorial. This was really meant to take you on my journey as I learnt about beacons and the different standards out there. And if you take nothing else away from this, iBeacons I don't think are the way to go for projects on the Raspberry Pi. I would go for URI beacons. If you search for URI beacons, you'll find more and more information out there. It seems to be a very active thing that's coming along, and it's open. So I think that's good. So that concludes it. Any questions?
How much do URI beacons cost to be? What kind of battery life do they get?
So I think these, you got 3 for about £40. Yeah, they've got a coin cell in there. This has been running for a couple of months now. I think they're expecting, over a year, if not a couple of years from it.
That's the coffee beacon, is it?
That's the coffee beacon, yes. Oh, I've got this.
I've just downloaded the app, and it takes me to a coffee shop that we mentioned. The physical web app.
A very nice coffee shop in Mill Road. I mean, you can get lots of boards out there. Again, go to the URI thing. It depends how often you broadcast, what strength you're broadcasting. If you're just broadcasting a URL, you can do it fairly infrequently, maybe 1 or 2 seconds. If you're trying to track movement, you probably want it less than a second, so you can get movement, but they last a long time, yes?
Everyone's got mobile phones. Has anybody written an app to make a phone work like a beacon? Because that would solve your problem for the hardware.
So right now, the Android operating system doesn't allow the phone to become a beacon. I think that is going to change.
But that would be the best way to do it, because everyone's got phones.
Yeah. Yeah. So I think that will come, but I think it'll be a very new one. And I think for my workshop, it would sort it out. There's another demo that Scott shows where he has a radio-controlled car that has a beacon, and so you can walk up to it with your phone, find it, click, you get on the web page for it, and you can control this car. I think it's very exciting technology. One of the things Scott says, and have I still got time? 15 seconds, all right. So one of the things that he says is, up until now, we have this app mentality when we're using smart things. You download an app. The problem is, as we get more and more smart things, we're not going to have that many apps on our thing. So you want to be able to go and find out what's around you, and then connect and interact with it. So I think it is, their physical web idea, I think it is very good. But I think this has got to be the last one.
Yeah, last question.
I've noticed on my phone when I normally get a little wonderful icons up, it might have a Costa Coffee logo.
Yeah.
Given the payload so small, presumably what's going on is it's just transmitting a URL, and something on the phone's going off and pulling in.
So what the app actually does is it goes off to a server and gets some of that additional information, but also, much as your Google search today tries to filter out spam and anything that it thinks may be malicious, it tries to do the same thing. So, and again, that is open. You can download and set up your own server for the app to check.
Okay.
Thanks very much.
Thanks very much, Barry.